For this lesson, you will need your workbook, pages 41 to 43, a pencil, an eraser, and a ruler. We are going to look at how we can solve problems using right triangles and SOHCAHTOA. Before we do that, let's learn two new vocabularies: angle of elevation and angle of depression. These two angles refer to specific situations when a person is trying to look up or look down. Let's first talk about angle of elevation. Consider this diagram on the left. The person is standing in front of a building. Normally, his eye will be able to see the face of the building through a horizontal line of sight. But if he decides to look at the top of the building, he will need to tilt his head up until he can see the top of the building. This angle between the horizontal line and this new line of sight is called the angle of elevation. Similarly, if we look at this diagram on the right, a person is standing at the edge of a cliff trying to look at a boat in the ocean. His horizontal line of sight is marked yellow. In order for him to see the boat, he needs to look down until he sees the boat. The angle formed between the horizontal line and this new line of sight is called the angle of depression. So why are these useful? Well, we can use the angle of elevation and depression to predict height of objects or distance between two objects. Let's take a look at example 1. We will try to draw a diagram to match the descriptions in the problem. From a point 8.5 meters from the base of a tree, the angle of elevation to the top of the tree is 36 degrees. Find the height of the tree to the nearest tenth of a meter. So from the base of the tree, we draw a horizontal distance of 8.5 meters. And from this point, there is an angle of elevation, so we are looking up to the top of the tree, so we know this angle is 36 degrees. And we are looking for the height of the tree, therefore we should define a variable for the height of the tree. We will use h in this case. So you can see we are looking at a right triangle with an angle 36 degrees, which means that the height of the tree is the opposite side and the distance 8.5 meters is the adjacent side. So if I see opposite and adjacent, which one of SOHCAHTOA, the primary trig ratios, does this remind you of? Did you come up with tangent 36 degrees equals to height over 8.5? So now we have set up this equation. We can cross multiply the 8.5 to the right side to isolate h, which gives us h equals to 8.5 times tangent 36 degrees. Use your calculator to simplify this further. You should get approximately 6.2 meters, which means that the height of the tree is approximately 6.2 meters. Let's look at a slightly more challenging example. Two buildings are 41.6 meters apart. From the roof of the shorter building, the angle of elevation to the top of the taller building is 44 degrees, and the angle of depression to the base of the taller building is 29 degrees. Find the heights of the building to the nearest tenth of a meter. So the diagram is given to us, but let's see why the 44-degree angle and 29-degree angle are located at where they are shown in the diagram. So when we refer to the angle of elevation and depression, we should mark a horizontal level, which is highlighted in yellow here. From the shorter building, we're going to look up to the top of the taller building. Since we're looking up, the angle of 44 degrees is called the angle of elevation. And from the top of the shorter building, where we look down to the base of the taller building, we have an angle of depression of 29 degrees. And then you have the variables x and y in the diagram, as well as the distance 41.6 meters. So the 41.6 meters between the base of these two buildings should be the same distance as the horizontal distance between the top of the short building to the front of the tall building. And do you see that variable x is actually the height of the short building here? And the height of the tall building needs to be the sum of x plus y. Okay, so let's start solving these triangles. We will start with the small triangle at the bottom. I have 41.6 meters next to or adjacent to the 29 degrees angle, and x is opposite from the 29 degree angle. Therefore, I have x over 41.6 opposite over adjacent equals to tangent of 29 degrees. Cross multiply the 41.6 to the other side. X is 41.6 times tangent 29 degrees. And so x is 23.1 meters according to my calculator. And this is the height of the shorter building. Then we can move on to look at the upper triangle. In the upper triangle, here is the 44-degree angle. I know the adjacent side is 41.6 meters, and the opposite side is y. Is opposite over adjacent again. So y over 41.6 is equal to tangent 44 degrees. We will follow very similar steps and say y is 41.6 times tangent 44 degrees, and use your calculator to find that y is 40.2 meters. We have done all the calculations for x and y. Let's put everything together. We still need to add up these two values to come up with the height of the tall building, which is 63.3 meters. And finally, we can conclude that the buildings are 23.1 meters and 63.3 meters tall. So this is the end of the two examples that I would like to show you. For the rest of the period, work on the questions found on page 42 and 43. Make sure you draw a diagram before you proceed to do any calculations.